Myself, Jasjivan Singh, Assistant Professor, Department of Mechanical Engineering at Khalsa College of Engineering and Technology, Amritsar. My subject is Basic Thermodynamics. So today I will cover the basics of thermodynamics, what is thermodynamics, system and its types, extrinsic and intrinsic properties, path and point functions, zeroth law of thermodynamics, continuum approach, microscopic and macroscopic approach, and all these will contain the valuable information for the new learners. So first of all, what is thermodynamics? Thermodynamics, it is a branch of physics that deals with energy and the work. Thermodynamics. So also we can simply define it that it is a branch of physics which studies about the heat changes to and from another energy forms. How the heat changes or how the heat transfers between an hot object and a cold object. So this is known as the thermodynamics. As about heat and the work. What is heat? Degree of hotness or coldness of a body or environment, it is known as the heat. What is work? Work, it is defined as physical displacement. If we are applying force and we are going to move at that object or the displacement of an object, that is termed as the work. In heat, the interaction is thermal. In case of the work, the interaction is mechanical. In case of heat requires the temperature difference, but in case of the work, it requires the force and the displacement. So, this thermodynamics, how this thermodynamics used in our everyday life. For example, consider melting of ice. Melting of ice and another can be the sweating in a crowded room. In case of melting of ice, we have to maintain a certain temperature below the freezing point of water to remain in a solid state. Sweating in a crowded room. Suppose you are in a crowded room with lots of people around you. After a few minutes, you will feel warm and will start sweating. This is based on the law of thermodynamics. How? Because as you feel warm, your heat is transferring to the sweat. As the sweat will absorb more energy, it will be evaporating energy from your body from more. So in this way, the heat transfer from your body to the air, and it is increasing the temperature of air in the room. So that is the sweating in a crowded room. So this is also based on the law of thermodynamics. Another example I can give, all the cars, trucks, buses, these are based on the law of thermodynamics and the Carnot cycle. So this is the definition of thermodynamics. Next, I am moving to the system. What is system and the types of system? System may be defined as a quantity of a matter or a region in space chosen for the study. Suppose what is general surroundings, everything else other than the system is surroundings, rest of the that is universe, and boundary it is separating the system from the surroundings. Example, consider a gas in a container and there is something reaction in the gas phase in the container and the walls of the container are the surroundings, and this in the system the molecules are acting there. So this is the system, surroundings and the boundary. Now the types of system. Closed system. In closed system, neither mass nor energy across the boundary of the system. That is termed as the closed system. Consider an example. Gas in a piston cylinder arrangement. Where the walls are closed is an example of the closed system. So in closed system, neither mass nor energy can cross the boundary of the system. So in closed system, the mass is fixed. Mass is fixed. No mass can cross the system of the boundary, but energy in the form of heat and work, energy in the form of heat and work cross the boundary of the system. In case of isolated system, neither mass nor energy can cross the boundary of the system. Is not allowed to cross the boundary of the system. Example, consider hot coffee in a thermo flask. That is the best example of isolated system. Open system. In this approach, within a prescribed region is considered, means you can say the controlled volume. In case of open system, both energy in the form of heat and work can cross the boundary of this system as well as the mass. So this is the system and its types. What is closed system, what is isolated system, and the open system. Next I am moving to path and point functions. All these concepts are considered so that for the new learners or those who are going to study first time the thermodynamics, this information will be quite useful for them. So what is path and point functions? First, what is point functions? The point functions means the point here, this is the pressure and volume diagram. The pressure P1 and the volume V1, it depends on the particular state at point 1. So P1 and V1 depends on particular state 1 and 2. Similarly, the P2 and V2 depends on particular state 2. So the point functions are those functions which depends on the particular states. So one state and two state. So the point functions, examples, internal energy, entropy, and enthalpy, all these are the point functions. So let here, this is dP, change in the pressure. So dP change in the pressure will be P2 minus P1. Change in the volume V2 minus V1. So these point functions are also known as the exact differential. Path functions. The path functions are those which depends on the particular path taken by a system. So as the process is moving from 1 to 2, so it has adopted a process that the process is moving from 1 to 2. So this is your particular path. So the path adopted by a particular process is known as the path function. Example, heat and work are path functions. Suppose for this process 1 to 2 heat, I am going to go 1 to 2 process, work done 1 to 2 process. So work done, that's it, 1 to 2. For path functions, the work 1 to 2 process cannot be equal to W2 minus W1. Why? Because it does not depend on the particular state. Only work can be calculated when the process takes place. So this is also known as the inexact differential. So this is the path and the point functions. Next, I am moving towards the sign conventions of work and heat transfer. These are very important because the students after the graduation they forget about the sign conventions of heat and the work transfer. Suppose this is a system. Work is done on the system. Work is done by the system. So let's take an example. piston above the weight is acting. So you are heating the gas. So when you are heating the gas, the gas molecules will take momentum and it will create the pressure on the piston to move forward. So when I create the pressure on the piston to move forward, the volume will increase and the pressure will decrease. This is an expansion process. So in case of expansion process, work is done by the system. So work is done by the system. It means the gas is acting on the weight. Gas is acting on the weight. So it means you are giving the work to the system. So expansion process, work is done by the system is considered as positive. Similarly, gas is there, piston is there, and you are applying more weight on it. What will happen? The gas molecules will become closer together, the pressure will increase and the volume will decrease. So it is a compression process. So work is done on the system. The weight is acting on the system. So work is done on the system is considered as negative. For the heat, there is system. You are supplying the heat. Heat is supplied to the system. Here heat is rejected to the system. If you are supplying the heat to the system, it is considered as the positive. If the system you are rejecting the heat, it is considered as negative. So one thing you have to remember in mind, that the heat conventions of sign conventions of heat and work are opposite to each other. So these are the sign conventions for the heat and work. Now I am going to move enthalpy, internal energy and the entropy. So what is internal energy? Internal energy is actually the sum of kinetic energy and the potential energies of the molecules in a system. That is termed as internal energy. Internal energy is represented by potential. What is enthalpy? Enthalpy is denoted by H. It is U plus P delta V or PV. So enthalpy H is equal to internal energy plus product of pressure and the volume. So enthalpy is very important because it tells us about how much the heat energy is there in the system. Example, an ice is there. So enthalpy tells us how much heat content is there in the thermodynamic system at constant pressure. This is termed as the enthalpy. So it tells us about how much heat energy is there in the system. Entropy. Entropy means degree of randomness in the system. For example, here ice is there and it melts. So it shows the disorder of the system. So this is known as the entropy. So it is a measure of disorder of the system. Another example of entropy, take a glass of water and put an ice in it. As the ice melts, it shows that there is increase in entropy of the system. So this is internal energy, enthalpy and the entropy. Microscopic and macroscopic approach. In case of microscopic approach, you are going to study the behavior of individual molecule, the study of individual behavior of molecules of, as I will say, fluid analysis of that particular molecule. Let us take a container. There are few molecules. So fix this particular molecule and study its individual behavior, the fluid analysis. So we can study the individual behavior of a particular molecule, that is termed as the microscopic approach. And this microscopic approach is significant if their molecules are very less, density is less. So this microscopic approach is significant when molecules are less. Microscopic approach, also known as the statistical thermodynamics, another name of. If these molecules are very close to each other, they are very close to each other, they are very interrelated to each other, the microscopic approach is not possible in this case. Macroscopic approach. In macroscopic approach, we are not concentrated on the individual behavior of molecule, rather we are concentrated on to study the average behavior of molecules in a system, gas system. So instead of studying the individual particular molecule, make some sections and then study the average behavior of the molecules. And this process is significant when the molecules are large. So macroscopic approach is significant when the molecules are large. Next is continuum approach. In continuum approach, again it is similar to macroscopic approach. We are not concentrated on a study of individual behavior of a particular molecule, but we are interested in average behavior of the molecules. So in continuum approach, the matter is considered as a continuous. So it is similar to the macroscopic approach. So this is all about microscopic and the macroscopic approach. Intensive and extensive properties. So intensive properties. The system is described by its properties. Let us take an example of water. You are heating it and the water is converted into steam. So water has certain properties like pressure, temperature. So all these are termed as the intensive properties. So intensive properties depends on the nature. Means the water boils at 100 degrees Celsius. Either we are increasing or decreasing the quantity of the water. Extensive properties. Water is there. It depends on the quantity. As you will increase the water, its mass will increase, volume will increase. So what are the extensive properties? The mass, example, mass, volume, all these are the extensive properties. So extensive properties depends on the quantity. Now I am moving towards the gas equation. PV is equal to nRT. State of system multiplied by the gas equation. PV the pressure of a perfect gas in kilopascal. V is volume in meter cube. M is mass of a substance in kg. R is gas constant. For air, the gas constant R value is 0.287 kilojoule per kg Kelvin for the air. T is your absolute temperature. And it should be in Kelvin. If the temperature is 0 degrees Celsius at 273 value, it will be converted into Kelvin. Specific volume is denoted by small m V. It means the total volume of that gas divided by its molecular weight. This R gas constant for air value is this, for carbon dioxide, for hydrogen, the values differs. So how this R gas constant value is calculated? It is equal to R bar divided by molecular weight of a gas. Its value is constant 8.314. So approximately the molecular weight of the air is 28.92. So you will get the value 0.287 kilojoule per kg Kelvin for the air. To understand the basic thermodynamic processes, the gas equation is necessary. Now I am going for basic thermodynamic processes. First process is isothermal process. In case of isothermal process, temperature is constant. So let us first draw the temperature and entropy diagram and also the pressure and the volume diagram. Earlier I have told that entropy is represented by S. So I am drawing temperature. T stands for temperature, S stands for entropy. In case of isothermal process, the temperature remains constant in the process. Suppose process is 1 it is moving to the 2. So process in isothermal process, the temperature remains constant. Pressure and volume diagram. After this isothermal process, I will move further to isobaric, isochoric, adiabatic, and then it will be the polytropic process. But before moving to isobaric process, one process kept in my mind that is very important, quasi-static process. So after isothermal process, I will go for quasi-static process, and what is thermodynamic equilibrium I will explain. Then I will move to the isobaric process. So in case of isothermal process, temperature is constant, gas equation, PV is equal to RT. For any thermodynamic process, R is constant. In isothermal process, this temperature is constant, so PV is equal to C. For the process 1 to 2, that values P1 V1 is equal to P2 V2. So P2 is rearranging this equation, P2 upon P1 is equal to V1 upon V2. So it follows the Boyle's law. Boyle's law states that the specific volume of a perfect gas is inversely proportional to the pressure at constant temperature. So isothermal process follows the Boyle's law. So before I move to isobaric process, I will explain the quasi-static and thermodynamic equilibrium. That is also a foundation for the basic thermodynamics. What is thermodynamic equilibrium? For thermodynamic equilibrium, if the chemical equilibrium, thermal and mechanical equilibrium coexist, then it is called thermodynamic equilibrium. So in case of thermal equilibrium, all the bodies have same temperature. So delta T temperature difference is 0. In case of chemical equilibrium, say reaction A plus B, C plus D, reactants products. So when the rate of forward reaction becomes equal to the rate of backward reaction, then the chemical equilibrium exists. In case of mechanical equilibrium, no unbalanced forces. So sigma is 0, sigma phi is 0, natural sigma z is 0. So in case of mechanical equilibrium, no unbalanced forces. So if the thermal, chemical and mechanical equilibrium coexist, then it is said to be thermodynamic equilibrium. Quasi-static process. the quasi-static process, the process in which all the intermediate states are in thermodynamic equilibrium, and the process is carried out infinitesimally very slowly. That process is termed as quasi-static process. I will explain how. Suppose this is your pressure and volume diagram. Gas is your piston and the weights. Suppose I am at this point. When these weights they have very less weight. When I am removing this weight, say I am removing one of this weight, what will happen? When removing the weight, what will happen? The pressure will decrease when I am removing the weight. Suppose I am at this point. The piston will move slightly forward. The piston will move slightly upward. So at that time, the system is in thermodynamic equilibrium. The stage is in thermodynamic equilibrium. The piston moves slightly upward, slightly. Above. So after moving another weight, I am getting one of the intermediate state, so I am writing this one. So all these intermediate states are in thermodynamic equilibrium. The process is carried out very slowly. That I am removing the weight and piston is moving slightly forward, upward, and that system remains in thermodynamic equilibrium. So all the intermediate states I attain are in thermodynamic equilibrium. That process is termed as the quasi-static process. So isothermal process I have already explained. Now I am going to the isobaric process. In case of isobaric process, the pressure is constant in the process. In case of isobaric process, the pressure is constant. So in temperature property diagram will be like this. So I know the gas equation, PV is equal to RT. So V upon T is equal to R on P. R is constant. In case of isothermal baric process, this pressure is constant. So I got the term V upon T is constant. So it follows the Charles law. According to Charles law, the V volume upon temperature T is constant. So for process 1 to 2, V1 upon T1 is equal to V2 upon T2 from the equation V upon T, or from the equation first. So rearranging this equation, I will get T2 upon T1 is equal to V2 upon V1. So it follows the Charles law. The Charles law states that specific volume of a gas is directly proportional to the temperature at constant pressure. So this is the basic thermodynamic process of isobaric thermodynamic process. So now I am going for isochoric process. In case of isochoric process, the volume remains constant in the process. Similarly, I am going to draw the pressure and volume diagram. So the volume is constant. Pressure and volume diagram. Process constant, volume process. Similarly, temperature entropy diagram, the process will be like this. So, what is the gas equation? So P upon T is equal to R upon V. For any thermodynamic process, R is constant, here volume. For isothermic process, it is constant. So I am getting the equation P upon T is constant. So for the values of process 1 and 2 will get P1 upon T1 is equal to P2 upon T2. So these are, you already know that this is the pressure and the temperature. So rearranging this equation, so T2 upon T1 is equal to P2 upon P1. So it follows the Gay-Lussac law. It states that the specific the pressure of a perfect gas is directly proportional to the temperature at constant volume. So it follows the Gay-Lussac law. These are the basic thermodynamic processes one has to understand in order to learn the first law of thermodynamics, second law of thermodynamics. These are the basic concepts. Now I am going for adiabatic process. In case of adiabatic process, no heat is transferred. In case of adiabatic process, no heat transfer. This process is an ideal process. It is also known as reversible adiabatic process. So the adiabatic process, it is done by pressure, volume, gamma. So PV raised gamma is constant. What is gamma? It is adiabatic index. And for air, the adiabatic index value is standard 1.4 for the air. So PV raised gamma is constant for adiabatic process. We know that PV is equal to RT. P is equal to RT upon V from this equation. So substituting this value in this equation, I will get RT upon V. V gamma is constant. So rearranging this equation, I will get T R is constant, T V gamma minus 1. So this is the adiabatic process. Now is the polytropic process. It is actual process followed by compression and expansion process. Actual expansion process as in nozzles, compressors, turbines, and the actual expansion also in IC engines and the compression in IC engines. So polytropic process is actual process. It is represented by PV and is constant. In case of adiabatic process, it was PV raised gamma, but here in case of polytropic process, it is PV raised N. So N is your polytropic index. So this is the polytropic process. Now we will see the basic difference between the adiabatic and polytropic process. In adiabatic process, it is an ideal process. Polytropic process, actual process. In case of adiabatic process, entropy remains constant. In case of polytropic process, the entropy changes in the system. In case of adiabatic process, if the entropy remains constant in the process is reversible. Reversible process means the process which returns after completing a cycle to its initial state. That is known as reversible process. In case if the entropy changes in the system, that process is irreversible. So I have given today, I delivered the basic concepts of thermodynamics, the basic thermodynamic processes, isothermal, isobaric, isochoric, polytropic and adiabatic process. Concept of zeroth law of thermodynamics, microscopic and macroscopic approach, intensive and extensive properties. Now, one of the interesting topic, as I told you, all the buses, cars and trucks, they are based on the second of thermodynamics and Carnot cycle. So, little bit introduction I will give you about the internal combustion engine. Internal combustion engine are those engines in which the fuel and air burnt inside the combustion chamber of the cylinder. So all the buses, cars, trucks, all these are internal combustion engines. External combustion engines. External combustion engines are those in which an external source is applied to burn the fuel and mixture in the engine. External combustion engines, example you can take steam engine, you are quite familiar with this, and the Stirling engine. Okay, that's all for the today.